Hello, welcome to my series on using the LogixPro 500 simulation software. In this episode, we are going to investigate doing exercise 3 of the garage door simulation. Now, if you haven't been through exercise 1 or 2, you need to watch my previous videos on doing that. And in this video, we're going to jump right into exercise 3. And to do that, we're going to modify our exercise 2 to make it into exercise 3. So let's pull up the student exercises, and they are found under your help menu under student exercises. Then you go to door simulation, and then you will see this screen, which will open up in your browser. The exercise 1 we've done in a previous video. Exercise 2 we've done in a previous video as well. Let's read what we need to do in exercise 3. First of all, they give you some background information, and I'm going to go through that by demonstration, so we're not going to read that. Let's see what they expect our program, our modified program, to do. If the door is fully open, the open lamp will be energized, but not flashing, as was the case before. In other words, when the door is fully open, the open lamp will be on steady or continuously. We did that in exercise 2. If the door is opening, in other words, if the door is in the process of opening, meaning that the motor is causing the door to actually open, then the open lamp will flash while the door is in motion. If the door is fully closed, the shut lamp will be on solid. If the door is in the process of closing, the shut lamp will flash while the door is in motion. Okay, let's stop there. The next two sentences have to do with the ajar lamp, and we'll come back to that. So with that information, what we're going to do is modify our program to get the shut lamp and the open lamp to flash while the door is in motion. So let's test our program. This is exercise 2. And we want to make sure that it works before we start modifying. So right now, the door is fully closed and the shut lamp is on. That's the way it's supposed to be. So now let's hit the open push button. Speed it up just a tad. The door is opening. The ajar lamp is on. And then the door fully opens. And then our open lamp comes on. Okay, so far so good. It looks like that exercise 2. Can we stop? Yes, we can stop. So let's close. And go all the way back closed. And now our shut lamp is on. That looks great. All right, let's go back to program mode. And what we're going to do is we're going to modify our program to flash let's do the open lamp first, since that's the next thing we're going to be doing is opening this door. So we have to go to the rung that has the open lamp. A mistake that I often see people make is they'll create a new rung. They're saying, okay, we need to do an additional step, or they're asking us now to flash the open lamp. So what they'll do is they'll come down and they'll create a new rung, and they'll put the open lamp at the end of the rung like this. And then they'll put in some programming to make the open lamp flash under the conditions where it needs to flash. In other words, when the door is moving up. The only problem with this is this creates a very unstable and to some degree an unpredictable program. To some degree. It is very bad practice and very poor programming to duplicate outputs on rungs. So we already have a rung where the output is the open pilot lamp. We cannot have another rung that has the open pilot lamp as an output. You can use outputs as inputs as many times and as many places as you would like to. In other words, here was motor up, and then we used motor up on its own rung, which is fine, but that's as an input instruction, not an output. So my first rule to throw at you is never duplicate outputs on multiple rungs. If you have a rung that has a particular output, such as the open pilot lamp, you can't have another rung where the output is the open pilot lamp. Okay, that creates inconsistencies in your program, and depending on the brand of PLC that you're using, it can create all kinds of issues. So just take it from me, stay away from that at all costs. Do not duplicate outputs on rungs, on multiple rungs. All right, so let's get rid of this rung. That was a mistake. We should not have done that. So let's cut it, get rid of it. All right, so, well then how do I make the open light flash? We already have a rung, and we are telling this particular open lamp to be on when the door is fully open. So if you want the open lamp to be on under other circumstances or other situations, then you have to modify this rung. You have to add or modify the programming on that rung for the open lamp to meet the new criteria. Okay, so the lamp is working fine, but we wanted to add a feature. We want the lamp to flash or to be on while the door is in the process of opening. Okay, so how are we going to do that? Well, the best way to do that probably is to create a branch around what we already have. Here, we're telling the open lamp to be open, or excuse me, the open lamp to be energized when LS1 is open. LS1 is open when the door is fully open. Now we're creating an OR logic situation saying that the open pilot lamp needs to be on or energized when the limit switch is open, meaning the door is fully open, or if the motor up is energized, meaning that the door is in the process of opening. Okay, that's pretty easy. We're going to put in an examine if closed, and it's going to be the motor up, just like that. So now we've created an OR situation, and we're not done, so hang on, don't get ahead. We're saying now that if the limit switch 1, if it's open, or if motor up is energized, meaning the door is moving up, then we want the open pilot lamp to be on. That's close, very close. The only stipulation, or the thing that we need to change, is it says if the door is opening, the open lamp will flash while the door is in motion. It won't be on solid. So remember that. We'll come back to that. But first we need to see if we have our lamp even on. We can't make it flash until we have the lamp coming on. All right, let's check it. Let's see what we have. Let's download and go to run. Currently the door is shut. The shut light is on. Let's hit open. Look at there. Now the door is opening and the open light is on. That's good. That's a first step. And then when the door gets fully open, the open lamp is on. That's great. Now if we close the door, the open lamp should not be on, and it's not because the door is not opening. All right, now we got to make a modification. Now we have the lamp coming on under two situations. If LS1 is open, or if motor up is energized. So let's go back to program mode. Now there's a little trick that you can use if you're using an Allen Bradley Slick 500 or previous model of PLC. So this would mean if you're using RS Logix 500 or previous versions of the RS Logix programming. This doesn't apply to RS Logix 5000 or the Compact Logix or the Control Logix series of processors. So LogixPro is built on the 500 series of Allen Bradley. So it also has this neat little technique or neat little trick that you can use to make a light flash. So let's go back to the run mode and let's click the data table button up here at the top. It's the one with the wrench and the hammer. And let's pull up the data table. In doing so, let's go to the status table. That's not a table you normally use. especially for beginners in programming. We don't normally do anything in the status table. We use outputs, we use inputs, we use the binary table to create flags. We use timers and counters and so forth. The status table, not quite as commonly used, but there's a neat little gem hidden in this status table that you can use to make a light flash. If you're in the run mode, you should see word 4 in the status table is a timer, or it's basically a counter it's counting up to its maximum value, and then it'll reset and count all over again. So it's constantly counting in the PLC. And if you change the radix to decimal, you'll see what it's doing. Look at there. It's actually just incrementing. It's counting up at some speed or some rate, which is determined by the scan speed of the PLC. And we can exploit that if we look at it in binary form. It's still counting up, it's incrementing. So whenever you're counting in binary, one of the unique aspects or characteristics of counting in binary is positions will alternate between binary ones and zeros in a symmetrical fashion. And we can use that to make something flash. So for example, look at bit position 4 right here. Bit position 4, see that? Starting at the right, at the least significant bit, that would be 0, and then 1, 2, 3, 4. So bit position 4, in word 4, that's S2:4/4. That's alternating 1 0 1 0 1 0 1 0 1 0 1 0, and it'll do that the entire time that the PLC is in the run mode. If you take the PLC out of run mode and go back to program, it halts. It's not counting. So be careful with that, because sometimes you may come here and you may say, oh, well, mine's not counting. Mr. Tyndall's was counting, but mine's not counting. That's because you're not in the run mode. Go back to run, and you'll see it'll pick up where it left off. Okay, so what we're going to do is we're going to add an instruction on this rung, and we're going to make the open light flash, but we only want it to flash while the door is in motion. So let's go to program mode, and we're going to add an instruction beside motor up. We're not going to put it over here, because if I put it here, it's going to cause the open light to flash under both circumstances, when LS1 is open and when the motor up, or when motor up is energized. And we only want the light to flash when motor up is energized. So make sure your instruction goes here. And then we're going to give it the address of S2:4/4. You can type that in where the question mark is. Just double click on the question mark. You can type it, or you can just simply drag this bit over there and then make sure that it's correct. S2:4/4. The 2 was not used because it's understood and it's dropped. So it's just S:4/4. And that's completely fine. The program's not going to keep the 2 anyway, even if you type it. And then I'm going to label this flash bit 4. And you can name it, some people call that timer bit 4, because they like to call this a timer, and in some ways it is. But we're exploiting the binary properties of this counting number to use it to make the light flash. And it's going to work great. All right, so let's bring this over here, and let's test it and see what we got. Download. Run mode. Look over here in our program. Notice now that that bit is flashing, and the instruction is flashing. It's corresponding to this bit, see that, in memory. So that memory location is toggling 10 10 10 10 10 10 10 and so forth, and it's causing this particular instruction to flash as well. And it's going to flash the whole time. Notice the lamp is not flashing. That's because we don't have a true condition on the rung yet that would allow the lamp to come on. Because remember, the lamp can only come on when the door is fully open or when the lamp is opening. So let's test it. Let's see what we have. Look at there. Now the door is opening and the open light is flashing. That's what we want. But let's make sure that it continues to do so even after the door gets fully open. That's going to be the trick, because when the door gets fully open, the open lamp should be on solid. And let's see if it does that. Yes, it does. So the door is now fully open and the open lamp is on solid. Hey, yay for us. So far, so good. All right, so now when the door closes, let's make sure the open lamp does not come on. It doesn't flash. It doesn't do any of that, because it shouldn't. The flash bit over here is still flashing, and it always will as long as you're in the run mode. That lets you know that you have that programmed correctly anyway. You gave it the right address. And if it's not flashing at the rate that you need it to, we'll talk about that in just a second. All right, that looks good. So it appears that our open lamp is now working properly for exercise 3. If you want the lamp to flash at a different rate, let's open up the data table and look at it. And if you'll look carefully at the bit positions, and you'll notice, okay, this one is flashing at a certain rate. It's like on and off maybe once or twice a second, something like that. If you want to go faster, if you want a faster flash rate, you'll pick the bit position to the right. See that one? And it's going to actually be flashing at twice the speed. Let's go back to our bit position 4. If you want the flash rate to be slower, pick the bit position directly to the left of it. And that will be half the speed. Okay? So you can adjust the speed of flash based on which bit position you choose. So we could change it from S:4/4 to S:4/5. We can go up a bit position, and then it would flash slower. Okay? So that's how you can control the flash rate. Now, one of the things you've got some control over in LogixPro is, first of all, let me go ahead and tell you that the flash rate in LogixPro will not be consistent. It's just the nature of the program. You also have the ability to speed up and slow down your program with this slider. See how it slows down? Or we can make it really, really fast. So depending on the speed that you have your scans set up here, determines the speed of this particular bit and all the bit locations really. So on a real PLC, you'll get more consistency out of this flash rate. But for this program, don't get too worked up if the flash rate changes on you, or sometimes it's a little faster than it was when you first programmed it. Lots of variables go into play, and it's not perfect. It's just a simulation software. All right, let's go back to our exercise, and we've got to do the closed light or the shut lamp. We got to do it basically the same way. So they're asking us that. They're telling us if the door is shut, the shut lamp needs to be on solid like it is now, and it needs to be on if the door is closing. If it's in the process of shutting, then the lamp needs to be on and it needs to be flashing. So it's almost like a very, very similar modification that we did for the open pilot lamp. So since it's a very similar request, I would assume we'd be programming it the same way. So let's bring down a branch and let's put it on the rung for our shut lamp. Remember, we don't add a new rung. We already have a rung for the shut pilot lamp. So we're going to add a branch around the limit switch 2, because now we're adding an alternative. We're saying that the shut lamp is on whenever LS2 is closed, or if motor down is energized, meaning that the door is in the process of closing. So we're going to program it the same way. We're going to put a flash bit next to motor down. And let's download and go to the run mode. And you'll notice that both of these bits, since they have the same address, they're going to be in sync with each other. They're flashing at the same rate at the same time. And so now, if the door is fully closed, our shut lamp is on. Let's open up the door a little bit and then hit stop. And then let's hit close. Look at there, the shut lamp is flashing while it's closing. But then when it gets fully closed, the shut lamp is on solid. Yay. Well, that was easy. So we've just took care of the open pilot lamp and the shut pilot lamp. Let's see what's next. The ajar lamp will flash if the door is stationary and is not in the fully open or the fully closed position. The ajar lamp will flash at a slower rate, a quarter of the speed than the other lamps. Okay, remember what I just talked about as far as the relationship between the bit position and the speed? So keep that in mind too. So, and then finally, the ajar lamp will be illuminated in a steady state or on continuously if the door is in motion. So they're telling us if the door is stopped like this, and it's not fully open or fully closed like it is right now, that the ajar lamp needs to be flashing. Okay, that's not too hard to do. Let's go ahead and make this ajar lamp flash. And so you've probably got a pretty good idea of what we need to do. And if you want to try this on your own, you can stop the video right now, and then you can attempt it, and then unpause it or come back to this location and see if you're right. So what we're going to do is we're going to add a flash bit on the rung with the ajar lamp. Again, we're not going to be creating a new rung for the ajar lamp. No need to do that. That's going to cause problems. So we're going to modify our existing rung, and we're going to add an instruction, and then I'm going to give it the address of the flash bit. Now, let's download and go to run mode. And you'll notice that now the ajar lamp would be flashing at the same rate as the shut lamp or the open lamp if they were flashing, because we gave it the same flash bit. They told us that the ajar lamp needs to flash slower, actually a quarter of the speed. So remember when I told you, let's go back and look at the data table. We're at position 4 for the open lamp. And I said if you move to the left one position, if we go to bit position 5, that's half the speed. And you can look at it and test me on that. But trust me, that would be half the speed. What happens if you move left of bit position 5? Well, bit position 6 would be half the speed of 5. And 5 was half the speed of 4. So if you move from 4 to the left 2 positions, that's a quarter of the speed. That's half of half. Half of $1 is 50 cents. Half of 50 cents is 25 cents. 25 cents is a quarter of $1. See the relationship there? Just basic math. So what we're going to do is we're going to pick bit position 6 for the ajar lamp. So let's go back to the program mode, and I'm going to double click on this address and change that 4 to a 6. So it's going to be S:4/6. Okay. And now let's download, and let's go to the run mode. And now you can see that the ajar lamp is flashing much slower than these flash bits that we're using for the shut and the open lamp. And the ajar lamp is flashing when the door is stationary. Okay, so far so good. So let's go back and read some more. The ajar lamp will flash if the door is stationary and is not in the fully open or fully closed position. Check. The ajar lamp will flash at a slower rate than the other lamps, a quarter of the rate or a quarter of the speed than the other lamps. Check. The ajar lamp will be illuminated in a steady state if the door is in motion. Okay. Okay. So we need the ajar lamp to come on solid if the door is moving and it's not fully open or fully closed. Okay. Let's see what we can do. Let's go to program mode. And what we need to do is we need the ajar lamp on solid. All right, so I think we can just bypass the flash bit. Can we not? Let's try that. So let's add a branch around our flash bit. Just experimenting here. And if the door is moving, in other words, if the door is moving up, then it'll bypass the flash bit if the motor is energized. And we got to do the same thing for motor down because the actual door can be moving in either direction. So we have to add an instruction for motor down, like so. And I don't really know. Let's test this. Just test this and see what we have. I think it's looking pretty good. Okay, the ajar lamp is flashing because the door is stationary. Let's open the door. Okay, when the door is moving, the ajar lamp is solid. Let's hit stop. And when we stop, the ajar lamp goes back to flashing at 1/4 of the speed. And let's open again. I'm going to speed up the program a little bit. And then the door is fully open. The ajar lamp goes off and our open lamp is on solid. It looks good. Let's close. Hit stop. The ajar lamp goes to flashing. But during the process of closing, our shut lamp is flashing and our ajar lamp is solid. Looking good, looking good. All right. And that may be it. Let's make sure that we've done everything. The ajar lamp will be illuminated in a steady state if the door is in motion. Yes. Okay. So that is exercise 3. So if you want to look at that, I can't show every bit of that in one screen. So I have to scroll down a little bit. And you can see here what we did is now when the door is ajar, meaning it's not in the fully open or fully closed position, then if the motor is energized, it bypasses that flash bit. So it doesn't allow the light to flash. It keeps it on solid. But the only way to do that is if the motor is actually, or if either motor up or motor down, because see, they're in parallel with each other. And so that kind of just bypasses the flash bit. So this was a neat little exercise. It sounds tricky, but when you break it down, take baby steps in it, it's really not that hard. The key is to reading what they expect from the exercise. They do give you some background information of that status file and how to use those bits to create the flashing effect. So you can read through that. But I wanted to demonstrate it to you in this video. I'll let you read all that on your own. So hopefully this has been helpful. I am going to save this. So I'm going to go back to the program mode and we're going to save this in our file where we've been saving all of our programs. This is garage door exercise 3. All right. Good deal. Thanks for tuning in. Be sure to catch some more upcoming videos on more student exercises here in LogixPro. Thanks a lot, guys.